Welcome to my presentation. This presentation is part of the playlist Integrals of Exponential Functions. In this presentation, we will be talking about the rules of exponential functions and also solving example problems. So let's talk about the rules relating to integrals of exponential functions. Okay. So let us say we have an exponential function e to the power of x. If we have to integrate that, integral e to the power of x dx, the rule states that when we integrate e to the power of x, it's going to be equal to e to the power of x plus c, where c is a constant. This is called the simple exponential rule. There is another similar rule, integral e to the power of u, if we have an exponent e to the power of u like that. So e to the power of u du by dx like that. Then the integral of these types of exponential functions can be written out as follows. Integral e to the power of u du. And then when we integrate e to the power of u, that is going to simplify as e to the power of u plus c. This is called the general rule of exponential rule. Okay. So now let us look at some example problems related to these simple rules. Let us say we want to evaluate this exponential function integral 2 e to the power of x dx. Okay, we're going to use the simple exponential rule to solve this example problem. Since 2 is a constant, we're going to take the 2 outside of the integral process. So we can write it out as 2 integral e to the power of x dx like that. So we know from the rule integral e to the power of x, when we simplify that, it's going to be e to the power of x plus the only additional thing we need to write here is plus c, where c is a constant of integration. So the problem integral 2 e to the power of x dx, when we solve it using this rule, it is going to simplify as 2 e to the power of x plus c, where c is the constant of integration. Let's look at another example. Let's say we want to evaluate this exponential function integral 2 e to the power of 2x dx. Okay, we're going to slowly add more and more terms just to illustrate as to how we can use these exponential rules to solve these functions. Okay, now we're going to use the substitution method to solve these types of problems. So we're going to say let u be equal to 2x. Let u be equal to 2x. Okay, so differentiating u with respect to x. Why? Because u is a function of x. So we're going to differentiate u with respect to x. When we do that, du by dx is going to be equal to 2. d by dx of 2x is 2. So we can write this as du is equal to 2 times dx, or we can express it in terms of dx as dx is equal to 1 over 2 du. Now we can substitute wherever we see u as 2x, and then wherever we see dx, we can write as 1 over 2 du into the given example problem and solve it using using the rules of integration. So when we do that, it's going to look like this. Our given problem is integral 2 e to the power of u. Instead of our given problem is 2 e to the power of 2x dx. Instead of 2x, we have replaced it by u as shown here. And then instead of dx, we're going to write 1 over 2 du as shown here. Integral 2 e to the power of u 1 over 2 du. Since we have 2 in the numerator and 2 in the denominator, those terms cancel out. We are left with integral e to the power of u du. We need to substitute wherever we have u with 2x, and that's what we started off with. We cannot leave our solution in terms of u. We need to express our solution in terms of x. So wherever we see u, we're going to replace it by 2x. So therefore, we can rewrite this one as e to the power of 2x plus c. So there is, if you want, there is one more step in here. Integral e to the power of u du, when we integrate that, it is going to be equal to e to the power of u plus c. But u is equal to 2x, so therefore we written it out as e to the power of 2x plus c, where c is a constant of integration. Let's look at another example. Let's say we want to evaluate this exponential function e to the power of x plus x dx, like that. Okay, we are going to use the exponential rule to solve this example problem. So e to the power of x plus x dx we can write as integral e to the power of x dx plus integral x dx. Since this is in parentheses, we're going to integrate each function separately, like that. So integrating each function separately, integral e to the power of dx, we know the rule states that e to the power of x dx is e to the power of x plus c1 plus integral x dx is x to the power of 1 plus 1 divided by 1 plus 1 plus c2. So c1 is the constant for the first term, c2 is a constant for the second term. So we can combine all of these together. E to the power of x plus x to the power of 1 plus 1 is 2 divided by 1 plus 1 is 2. So e to the power of x plus x squared divided by 2 plus c1 plus c2. c1 is a constant, c2 is another constant. So we can combine constant 1 and constant 2 and then make it another constant called c. So therefore, we can express this one as e to the power of x plus x squared over 2 plus c, where c is equal to c1 plus c2, constant 1 plus constant 2, where again, where c is a grand constant of which combines c1 and c2. Okay. So this is the way we're going to solve example problems related to integrals of exponential functions. In my next video presentation, we will be solving more examples related to integrals of exponential functions.